Hello guys, in this video I am going to explain the solution of question number 73 of chapter 10 from the book Engineering Circuit Analysis by Hayt, Kemmerly and Durbin. So the question says that for this circuit we need to calculate the values of IL, IR, IC, VL, VR and VC, right? So to determine this, to get the values, over here we are going to use the concept of impedance. That simplifies our calculation drastically. Already in the circuit, impedances for the inductor and the capacitance is given, so simply we are going to use this concept. And impedance concept says that since the inductor and the capacitor, since they are represented in ohms, so we can follow the theorems as it is. So over here, since we have a single node, right, this can be considered as a reference node. So we will use the nodal analysis to solve this particular circuit. And using the nodal analysis, remember, you do not need to worry about this presence of this inductor or the capacitor, because they are already in impedances. So simply you will consider them as a resistance while writing a nodal equations, right? So over here, let this node be A and let the voltage over here, let it be V. So if V is the voltage, so we have three currents, this current and this current, right? I1, I2, I3. So writing a KCL at node A means, so it will be I1 plus I2 plus I3 equal to 0. Now I1 current is flowing in this direction, so the voltage, the I1 will be expressed as V minus Vs upon 2.5 J, which is the impedance between V and this source. I2 is the current flowing through this 2 ohm, so it will be V minus 0 because this is 0 volt, right? So V upon 2. V3, now V3 is this current, I3 is this current, so it will be V upon impedance, which is minus J, right, equal to 0. And now once we get this equation, we will try to solve this one. So over here, this first expression, like this can be, like we can V upon like 2.5 J, so we can multiply divided by JJ. So this J square, we know that J square is equals to minus 1 because J is root minus 1, so J square is minus 1. So in the denominator we have minus 1 and this is 2.5, so just removing this we get 10 over here. This is 2, this is then 5, so 2 divided by 5, it is 0.4, right? So simply it means that we can write it as 0.4 J and V minus Vs. So this first term can be written as this. Second term, it is V by 2, so simply we can write it as 0.5 V, right? And the third term, it is V upon minus J. So again, for this V upon minus J, we can divide and multiply it with J minus J. Now J square, it will be minus 1 into this minus, it will be plus, so we will simply get JB, right? So we will get JB equals to 0. So from this first equation we get this second equation. Now taking all the V's together, we will get V as a common, so we will get minus 0.4 J plus 0.5 plus J, right? And this Vs, since it is negative over here, so we can bring it like it will be 0.4 J Vs equal to 0, right? Or taking this term on the right side, simply we can write it as minus, right? So our V, now our this can be expressed as minus, and this is minus 0.4j and this is plus j. So this will be written as 0.5 plus 0.6 j equals to minus 0.4 jVs. Right? Now V is equals to minus 0.4 jVs upon 0.5 plus 0.6 j. Right? And you can, like, this can be solved in any way. I will use this way, like Vs, and I will bring this minus 0.4 j in the denominator of this. So it will be minus 0.4 j plus 0.6 j upon minus 0.4 j. So this can be expressed as Vs upon minus 1.5 plus 1.25 j. Okay, 1.25 j. So, and now what is Vs? Coming back to this, our Vs is, it is 100 angle 0, right? 100 angle 0. So substituting it over here, 100 angle 0 upon, now if you convert this 1.5, this 1.5 minus 1.5 plus 1.25 j, this can be converted into the polar form, and converting it into polar form, you will get 1.95 angle will be 140, right? So substituting this, we get this, right? And now we know that if the two expressions are in polar form, then the final answer will be, and the angle will be subtracted, right, like this. So we will get the answer as 51.28 angle minus 140 degree. So this is our V. This is our V in volts, right? So what we did overall, simply overall for this question, we simply write, considering this as a node, we simply write the nodal equation, and then once we get this equation, then simply we solve it mathematically, and solving it mathematically, we come to this part, and from this we convert this denominator into the polar form, and then using the mathematics related to the polar form, we get the expression for V. V is the node voltage, right? Now once we get a node voltage, once we get V, right, now what we need to determine, we need to determine all the current and all the voltages, right? So our VR, now since this is V, so our VR, it will be equals to V. Our VC, it will be equals to V, right? Because there is no other, like in this branch, there is no other resistance or impedance. In this branch, there is no other source or the impedance or the resistance. So VR will be equals to V. VC will also be equals to V. What about VL? Now VL will be the difference, like between Vs minus V, right? It will be the difference between Vs minus V, right? So this will be our now what is V? We got our V. Our V, it is this 51.28 angle minus 40. So same thing, I am going to write it over here. So it is 51.28 angle is minus 140 degree volt. It is 51.28 angle is minus 140 degree volt. And for this it is Vs, it is 100 angle 0 minus V is 51.28 angle minus 140. So if you solve this, how you are going to solve this? To solve this, first you need to convert this polar forms into the complex number form, rectangular form. So this 100, it can be expressed as it can be expressed as 100 plus J0 minus this 51.28, it can be expressed as minus 39.28. Let me erase this from here. 39.28 minus 32.96J, right? And now mathematically solving it, we get 100 minus 39, so it is 139.28, and then this is J0, this is minus 32, so plus 32.96J, right? And once we get this expression, now this complex number can be converted into the polar form, and you will get something as 143.13 with angle as 193.31 degree. So this is our VL in polar form. Unit is volts, right? And now once we get VR, VC and VL, we can get our IL as it will be VL upon impedance. Now remember, over here you do not need the formula LdI by dt type formula, or to get the inductor current you do not need any integration, right? It's something like this. So because we have the impedance, so we will use the formula similar to the resistance formula. So it will be current, inductor current will be VL upon impedance of the inductor, right? So if you solve this, you will get 143.13, it is 193.31, and this, if you convert this J2.5, it is J2.5 means 0 plus J2.5, right? So this will be 2.5, angle will be 90. So substituting this, we get 2.5 angle 90. So solving this, what you will get? You will get the answer as 57.25, and angle will be 193.31 minus 90. So it is 57.25, angle will be 103.31, right? So this is our amperes. Now similarly you can do for the IR and IC. Now just a minute. So IC will be VC upon impedance, like the impedance of VC, it is this minus J. So it is minus J, and for this minus J, VC it is 143.13, angle 193.31, and for this minus J, it will be 1 angle 270, or it can also be written as this minus 90. So let me put minus 90, and it will be 143.13, angle will be 193.31 minus 90. So it is 140 minus minus, it will be minus minus, right? Minus minus 90. So it will be 143 point, and this will be like 190. So it is 283.31. 283.31. And just a minute, 270 minus, okay, I put it wrong, because VC it is, angle is minus 40, angle is minus 140, right? It is 51.28, angle is minus 140, so it will be, I need to change over here, it is 140, just a minute, it is 51.28, it is 51.28, angle is 140 minus 140, right? Yes. So let me erase this. So it is like, if you solve this, you will get 51.28, and angle will be minus 140 minus minus 90. So this will be 51.28, angle is minus 50. So this is our IC, amperes. And similarly, I can get the resistance current IR, which will be VR upon resistance is 2, right? Resistance is 2. So VR is 51.28, similar to VC. So it is 51.28, angle is minus 140 upon 2. Now this 2, it can be written as this, because this 2 can be written as J0, and if you find the magnitude, it will be 2, angle will be 0, right? So this can be written in this way. And simply, if you solve this, 51.28 by 2, angle will be minus 140 ampere, so it will be 25.64, angle 140 ampere. So this will be our IR. So in this way, just with the concept of impedance, we can easily determine the voltage and the current through any element of the circuit. The only thing that we need to know is the knowledge of the complex number and the polar form, that how we can convert this complex number into the polar form and polar form to the complex form, right? And remember that when you need to add the two numbers, then it is always better to add the numbers in complex form, and when we need to divide or multiply, it is always better to multiply and divide the numbers in polar form, right? Because the angles, in that case, the angles, like in division you need to subtract the angles, in multiplication you need to add the angles. So this is the solution of part A. For the part B, it is mentioned that using the scales of 50 volt to 1 inch and 25 ampere to 1 inch, means it is saying that if the voltage is 50 volt, then we need to use the size of the vector as 1 inch, and if it is 25 ampere, then for 25 ampere we need to use the scale of 1 inch, right? But over here, since it is not possible for me to demonstrate over here, so I will not use this. Now next, show all these 7 quantities on a phasor diagram and indicate that IL, IR, IC and VS, VL, this IL is equals to IR plus IC. Now what it means, like over here I got these 3 currents, right? I got these 3 currents. So if I plot this on a graph, so IL, like it is 57, angle is 103. So this IL can be drawn like 103, angle 103. It will be lit somewhere over here, right? it is 103.31 degree. So this will be our IL, right? If we look at IC, it is 51.28, angle is minus 50. So it is 0 degree. We know it is 90 degree. We know this is minus 90, and this is 180, right? So if it is minus 50, so this will be somewhere over here 50, right? And this will be our IC, right? And then the third IR, it is 25.64, angle is minus 140, so minus 40. It means we are going to go in anti-clockwise direction. From 0 degree I will go in anti-clockwise direction. So up to this point it is 90, so I need to go 50 degree more, so it will be this, right? IR, so it is 140 degree, right? So over here with the length, when over here you can see the magnitude of IL, it is 57.25, means it is the maximum. Then the length, this IC magnitude, it is 51.28, and IR, it is the minimum. So when we draw the phasor, like these are known as phasors, right? And this complete diagram, it is known as phasor diagram, right? So over here when we draw these vectors IL, IR, RC, so we can note the magnitude also. So over here, since the magnitude of IR is minimum, so instead of this length we can have less length, right? Magnitude of IL is the highest, so we can increase, like we can draw the length of the IL as the highest. And similarly for this IC, it is in between, so we can draw in this way, IC, right? So the length, because we know in the vectors the length of the arrow indicates the magnitude, and the angle that it makes with the 0 degree axis, it is the angle that vector is making, right? So over here you can see this is our IR, this is our IC, and this is our IL, right? So they are the proper vectors, and vector algebra can be implemented over here. So, and this is what is mentioning over here, that when it says that IL, indicate that IL is equals to IR plus RC, so it means that over here we have these two vectors. If you do a vector sum, like if I bring this IR over here, right, so I will get my angle, it will be something like this, right? You can see the direction, this will be our IL, this will be our IL. So if I do the vector sum of IC and IR, I will get IL, right? So vector sum of IR and IC will give me IL, right? So over here the angle, like the angle of this is not visible exactly in this form, right? But if you are going to calculate it numerically, you will get the same angle. So this I am not going to solve, because otherwise it will be little bit complex for you to understand. So but this is the concept, that the phasors are the vectors, and vector calculations, vector mathematics can be applied over here, right? And similarly, if we look at this VS, VL and VR, same concept is over here, that over here VS, VL and VR. So let me put it over here. So over here our VS, it is 100 degree, 100, angle is 0 degree, so this arrow will be this is our VS, angle is 0 degree. Now the next is VL, because it is VS equals to VL plus VR, and it is vector, right? So VL, it is this, right? Sorry, VL is this. It is 143. Angle is 193. So 193 angle will be, this is 180. So 193, it will be somewhere over here. And since the length of this VL, it is 143, it is more than that of VS. So we need to, length of the vector should be more. So it is VL. And this angle, it is 193.31. And from this you can note down that we can also, instead of 193, we can also say that it is like, it is 360 minus 193, but then it will be in negative form, right? So we can have this angle as 166.69, but in negative form, right? So 193 is equal to minus 166. And the third is VR. Our VR, it is this. So 51.28, and angle is minus 140. So 140 angle, it will be over here. So this is our, let me reduce the length. It is VR. Angle is 1 minus 140, right? So now over here, if you do a vector sum of this VL and VR, then you will get this VS, right? So this is how you can represent this on a phasor diagram. So with this, I end this video. If you have any doubt, you can put it in a comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.